All right, good morning or afternoon whenever you guys are watching this. So this is the list of things we need to do on Tuesday, Wednesday of this week. So either October 20th or 21st. If you guys are watching this, then I am not back at school yet. I have a family situation I'm trying to deal with. Everything's fine. Don't be alarmed. Don't be worried. I am making these videos so you guys don't completely fall behind. So hopefully we are still able to watch this and listen and get the full extent, just like if I were there. So this is what we are responsible for doing today. All of it is in Canvas. First thing is good things. I'm always looking for some positivity. So you guys tell me a couple of things going on in your life, something you're looking forward to, or something that makes you happy. Number 2 is the warm-up, F equals MA discussion. So basically, give me a unit of measure for force, a unit of measure for mass. We talked about quite a bit of them for mass, and the unit of measure for acceleration. SVA notes in your journal. We're going to do these together here in a minute. Brain Pop, acceleration. There's a video and a quiz, and I even put the YouTube version of it in Canvas so you can watch it on your own at home as many times as you need. You have 2 practice assignments. These are both worksheets, and you can either annotate on the worksheet, you can submit your answers as a text entry, or submit a photo of your completed work. And then also you should have noticed that 5 sets of your notes need to be turned in. If you haven't done it yet, for those of y'all who have, awesome job. If you click on the assignment, it tells you which 5 I am looking for, and you need to either submit 5 photos or a video of those sets. And I even put the dates that we did them to kind of help you find them. So I'm going to give you another couple seconds to look over everything we're doing. All right. So let's take a look at what we're doing today. Our notes today, let's go ahead and put the date. It is October 20th if you are A-Day, so that is Tuesday, or October 21st if it is B-Day. Again, just depending which day it is that you guys are watching this. Our title is speed, velocity, and acceleration. The good news is this is pretty easy stuff. It's really just figuring out what the difference is between each one and comparing them. So we're going to start with speed. Speed is distance traveled in a certain amount of time. The formula for speed, now this is going to be on your formula chart that's on your periodic table. The formula is speed is equal to distance over time. Then we're going to look at an example. A dog runs 15 meters in 3 seconds. Now, just like we did before, we could solve using our guess method, but we're not going to be working on that today. We're going to do that more on Thursday and Friday. So for now, we're just going to plug the numbers in. So basically, we have our distance, which is 15 meters, divided by the time. So 15 divided by 3 equals 5 meters per second. So it's just like when you're driving and you hear them say 70 miles per hour on the highway. That is the speed. If you were to travel at that same constant speed for 1 hour, you will have gone 70 miles. So that is speed. The next term we're looking at is velocity. So velocity is speed in a given direction. And it must include both. So we need to have speed and we need to have a direction. There's no actual formula for it because it's basically the same formula, just with the direction. So you just want to add north, south, east, west. So for example, a hiker climbed 1,800 feet in 60 minutes, so in 1 hour. Headed northeast. So it's essentially 1,800 feet, our distance, over our time, which gives us 30 feet per minute to the northeast. Now again, we're going to work more with the formula next time. But the important part is that we understand it is a speed with a direction. We have one more term to define, and that is acceleration. Now, we touched on this a little last class, so we should all be at least somewhat familiar with what acceleration is. Let me move this over a little bit. Acceleration is the rate of change of velocity. So it's essentially a change in speed and or direction. So it could be speeding up Let's write these as some of our examples. Speeding up. It could be slowing down. That's what we consider a negative acceleration. It could be changing direction. If I'm running and I'm running at 6 miles per hour, and all of a sudden I turn to my left without changing my speed, my acceleration still changed because I changed direction. My velocity was affected. So if an airplane slows down from 800 miles per hour to 200 miles per hour to land, the plane accelerated. Why? Because its speed changed. It slowed down. It went from 800 to 200. Most of the time we think of acceleration as speeding up, but that's not always the case. It can slow down, or it could just be changing direction. Now we're going to do one more thing, and I'm actually going to call it my SVA diagram. But before I do that, I'm going to highlight some of these terms. Y'all know me and my color coding. So I have speed. It is distance and time. Here's my formula. Then I have velocity. It is speed and direction. You need both. We'll leave that one like that. And then we have acceleration. It's the rate of change of velocity. Speeding up, slowing down, changing direction. So I'll give you another couple seconds to look that over before I start on our SVA diagram. I'm actually going to do it on another page, but if you guys have room here and you write small, you're welcome to do it there. I don't really write small, especially when I'm writing for y'all. Or you can do it on the back. Again, the pens I use are dark, so the back isn't really the best option for me. But in my personal journal, I will probably do it on the back, if not down here. Okay. So since I am going to start a new page, and if you guys still need those notes, you can always go back and pause the video. But since I am doing a new page, I'm going to call it SVA diagram. Again, this is 10, 20, 20, or 10, 21, 20, depending on which day it is. So I'm going to draw, again, I'm not a good drawer, but that's okay. Kind of like a race track, and we're gonna label where there's acceleration and where there's constant velocity. Remember, if there's constant velocity or constant speed, There is no acceleration. If there is acceleration, then the velocity and speed are not constant. So let's see if I can draw this kind of decently on the first try. Okay. There we go. So this is kind of like a road. It's about as good as it's going to get. And then I'm going to put right here is my start / stop. So let's pretend this is a track and we are lined up here and we're going to run a 400, which is 1 lap around. So as soon as we start right here, we're going to have acceleration. We know that we're going from being not moving to starting off really quickly. And then the same thing is true when we get to it as a finish line. As soon as we cross that finish line, our acceleration, we have acceleration because we're slowing down. About right here, we have constant velocity. Because our speed levels out. Then at the turn, we have acceleration. So every turn, we have acceleration. We're changing directions. And then every time we're at a straightaway, we're at constant, every time we're at a straightaway, we're at constant velocity. And we're going to write what those terms mean. So my accelerations are green. So every time we change direction, notice if we start here, we're running east, then we turn up and it's a north, and then west, and then south. So essentially our direction is changing as we're running this lap around the track. And then our constant velocity is when everything is the same. So acceleration is at the curves and at the start or stop, because we change speed. Well, at the curves, we're changing direction. So the curves is the change of direction. And then at the start, stop, we change speed. And then acceleration is green. And then our constant velocity is on the straightaways. So this is when nothing is changing. All right, so that is it for our notes. I'm gonna leave this up for a couple more seconds, and then I'm gonna go and put up our things to accomplish today, if I can find where I put it, just for a couple more seconds. Again, if you guys need to go back and rewatch anything, please do so. I made this video for you guys, so you know exactly what is expected, and I'm hoping that it'll simulate me being in the classroom as closely as possible. So this is your things to do. Hopefully by now you got that done and in your journal. Again, if need be, go back and pause this so you can get it done. Good things. Warm up. Brain pop 2 practices, and then get photos or videos of your notes. Feel free to message me through Canvas if you guys have any questions or concerns. Again, I really hope I can see you guys soon. I miss y'all. I miss talking to anything that's not just a camera. But I will see y'all soon. Again, message me with any questions. All right, bye.